Good morning, judges and fellow innovators. We are the RiceCyclers, presenting our project Transforming Waste Rice into Sustainable Plastic. Hi, my name is Calix.
My name is Javin.
And my name is Xavier.
Today, we are here to talk about our project for the WSDG 2025 World Sustainable Development Goal Challenge. Our project is titled Bioplastic, Transforming Waste Rice into Sustainable Bioplastic. It aligns with two key UN Sustainable Development Goals, SDG 11, Sustainable City and Communities, and SDG 13, Climate Action. Our project begins by identifying major problems that are currently happening in the world, namely food waste and climate change. Rice is a staple food for many students, and a significant amount is wasted each day. When waste rice ends up in landfills, it decomposes and releases methane gas. Methane is a greenhouse gas that is far more potent than carbon dioxide and is a major contributor to climate change. In fact, in Malaysia, food waste is responsible for producing between 71 and 147 gigagrams of methane. The exact contribution from rice isn't separately quantified, but it's a significant portion. This is a massive problem and is one we wanted to tackle the most. To tackle the problems, we developed a smart solution, the RiceCycle app. This app helps users manage their waste by using AI-driven classification. The app utilizes teachable machine to look at waste through the camera and identify what type of waste it is, such as rice waste. It provides instant user feedback, telling them where to throw the waste. For example, food waste bin. This not only educate users but also help us collect rice waste effectively for recycling into bioplastic. Moving on, the waste rice we collected was transformed into bioplastic through a simple 6-step process. Firstly, mix waste cooked rice with water. Then, blend the mixture until no chunks of rice are left. Next, mix glycerin and vinegar into the mixture. After that, heat the mixture on low heat. Once mixture is thick and sticky with a gel-like texture, remove from heat. Lastly, spread the hot mixture on a baking paper and let it dry. To encourage others, we even organized a hands-on workshop at our school. During the session, we demonstrated each step of the process. Students not only observed but also participated. Alongside the practical activity, we shared information about food waste, its impact on climate change, and how small action like recycling rice can make a big difference.
In our study, we applied the pseudo-second order kinetic model to describe how our rice-based bioplastic breaks down. This model shows that the rate of degradation depends on the square of remaining mass. So when there is more bioplastic, it breaks down faster, but rates slow as less remaining mass. On the molecular level, soil microbes release enzymes like amylase or cellulase, which cut starch molecules into smaller sugars. These sugars are then consumed by bacteria and turned into carbon dioxide, water, as well as biomass. Moreover, our outcomes show that the experimental data fit the model almost perfectly, with an R-squared value of 0.9922. That means our prediction and the actual biodegradation process match very closely. This tells us that our bioplastic is strong enough for short-term use, like bags or packaging, but it will still decompose naturally over time. In short, the enzyme reactions make it biodegradable, and our model proves that the process is reliable. Simultaneously, the impact of this project is significant. It contributes to the reduction of food waste by diverting rice from landfills, which reduces methane emissions. On the other hand, our project also has the potential to lead to lower waste disposal costs for restaurants, hotels, or even households by selling their waste rice for conversion. Besides, we also raising public awareness of sustainability by educating communities on the value of reusing waste rice. Ultimately, this project contributes to a healthier ecosystem by improving biodiversity, and water quality. Subsequently, our experiment was done using readily available materials and equipment. The materials included waste cooked rice, glycerol, vinegar or citric acid, and water. The equipment used was also easy to get, such as beakers, a digital scale, a spatula, a mixing bowl, a Bunsen burner, baking sheets, as well as the protective gears. This shows that a bioplastic like this can be made without complex or expensive resources.
Of course, we faced challenges along the way. The primary challenge was the presence of impurities in the waste rice, such as oil, salts, and spices, which can interfere with the polymerization process and make the bioplastic weak or brittle. Another issue was consistency and scalability, as it was difficult to get the same plastic like material every time due to the varying quality of waste rice. The gelatinized nature of cooked starch also made it harder to form consistent films or sheets compared to raw starch powders. Through this project, we learned two major lessons. First, we realized that waste can become a resource. Instead of being thrown away, rice can be transformed into a useful product, supporting sustainability. Second, this project highlights how common food waste like rice has hidden potential, changing how we view our daily waste. Our work is supported by existing research. Studies show that bioplastic often require less energy to make and produce fewer greenhouse gases than regular plastic. Biodegradable bioplastics can also be broken down naturally by microbes into water and carbon dioxide, which help reduce plastic pollution. Rice bioplastics are particularly promising for applications like packaging, agricultural films, and medical disposables, leveraging their strength, biodegradability, and thermal properties. In conclusion, we are the RiceCyclers. We are transforming the future one grain at a time. By turning a common waste problem into a sustainable solution, we hope to inspire others to rethink their waste and contribute to a more sustainable world. Thank you, and signing off.